Good morning. Let's have a class, and we will move on to exam 2. Exam 2 lectures will focus on the bacteria caused the disease, which is infectious disease caused by bacteria, and we will talk about antibiotics and antimicrobials and the control of the microbial bacteria. So we have finished the exam 1, and I will start to upload the grade this afternoon. Some students we finished the grading, some are not, but gradually put onto the e-campus. Exam 1 relatively is easy. Exam 2, what you will see the difference is in the classroom is somebody is doing really good. Some people doesn't do very well at all, because all of a sudden we will have lots of the bacteria. Lots of the bacteria name you may heard about somewhere, you may not studied it before, you may not learned. And we also will have lots of the case studies. The case studies, we'll have a practice case study for you. So this makes this exam 2 looks like two different category of the whole classroom. Okay, so just want to let you know the situation. But if you are doing those practice exams and you're attending the classes and even watch the videos after that, then you should be fine. So lecture 1, human disease caused by bacteria, we will talk about is most of the pathogen is respiratory tract caused infectious disease. So here is a little bit anatomy, which is talk about the respiratory tract. We're not going to go over all of these. We just want to mention several things. The key of the difference between, or we say separate, the upper respiratory tract and the lower respiratory tract is epiglottis. And the epiglottis, you know that it's a very soft bone. And when you're eating, it's closed. When you talk, it's open. So you heard about when you were very young, in the kindergarten, your teacher or your parents will say, please do not laugh or talk when you eat something, because the epiglottis is soft bone, they will be open, and the food will go to the respiratory tract, then will cause choking sometimes. Is that right? That's something we want to talk about that. Another thing we want to mention is the tonsil. We will have a lab later on. We'll do is clinically identify a bacteria from the tonsil area. Because tonsil is a reservoir for lots of the pathogen. And, but some of you do not have the tonsil. The tonsil has been taken out when you were very young. But we will mention some of the bacteria started from there. Okay? So that's something what we want to say. And also today, lots of the things we will talk about is also in the lung area. So we have a bronchi, alveoli, all those areas is the infectious area. Now, one more thing we want to mention, in our respiratory tract, we also have a huge number of the normal bacteria. The normal bacteria which is hiding there or staying there, which is give you a very good bacterial community, but if the condition changes, especially as the weather changes, they will be translocated. So we call those bacteria which is opportunistic bacteria, which means the bacteria looking for opportunity to cause a problem. That's why when the weather changes, turning from summer to fall, from winter to spring is always a tricky time. You will get a cold virus, you will get the bacterial infections all the time. That's part of the reason. So we will talk later on. This is an overview of majority of the pathogen. We will talk about this one by one. So that's a very good table. Not every single item, but we will mention some of them. Diphtheria. This is the first one we will talk about today, is Corynebacterial diphtheria. Bordetella pertussis, which causes whooping cough. Then a bunch of the bacteria was called ammonia, which is Streptococcus ammonium, Staphylococcus aureus, Legionella, Mycoplasma, and Klebsiella ammonium. And Streptococcus infection, Streptococcus pyogenes, bunch of the bacteria cause meningitis we'll talk about today. including Haemophilus influenza, Neisseria meningitis, Streptococcus pneumoniae, and one we already mentioned, which is Mycobacterial tuberculosis. So we basically, this is your outline, what we're going to talk. Not everything go very detailed, but lots of the things we will talk about that. To the pathogen, I will do a brief introduction here, which is Legionella pneumonia. So the Legionella, this is the one, is coming from an Army convention in 1970s, an Army convention in Philadelphia has an outbreak. So the convention in Philadelphia, lots of people to join that convention, and then afterwards they go ahead to take the shower. And after shower, the second day and the following couple of days, among like 70% of them is contaminated with Legionella. And the symptom is very similar to the pneumonia, which is you have a chest pain, cough, sneezing, high temperature, fever, all those things. But it will recover a couple of days later. Because this important outbreaks, they have this called Legionella. And this is a pathogen widely existing in aquatic systems, even including our air condition. Okay, in a very wet area, the air condition, all those things could happen is a Legionella. And also Legionella is one of the pathogens, is zero tolerance in our drinking water system. So our drinking water also need to test in the Legionella to see whether the presence and absence, it's a zero tolerance, which means not allowed to have one cell there. This is something we'll be very briefly introduced to you. The second one I want to mention is a Mycoplasma pneumoniae and ammonium connoni. And those two will cause walking pneumonia. That means this ammonia will be recovered by itself after very mild symptoms, couple of days, without any treatments, any of the medicine. So that's called a walking pneumonia. Which means the seriousness compared to Streptococcus pneumoniae, Streptococcus pyogenes, that's relatively mild. Okay? So these are the things we very briefly talk. Then we're going to go detail to talk about a couple of the pathogens. Today I think we'll talk about Corynebacterial diphtheria, and we're also going to touch the base of the meningitis. So this is Corynebacterial diphtheria. Corynebacterial diphtheria. I want to make sure it is spelling correct, diphtheria, okay? Corynebacterial diphtheria, we review what we learned in exam 1. Genus name and species name. What means the corner? This is coming from a Greek word, means club. This is related to the cell arrangement of a bacteria and very typical for Corynebacteria. Diphtheria, this is a toxin. Diphtheria toxin we will mention. So, what we learned in our exam 1, in the lab section, in the lecture section, will be very useful right now. What is the characteristics of is Corynebacteria diphtheria? This is gram-positive, large shape, morphology, and club arrangement. What is club arrangement? Looks like this, looks like that, or looks like that. Two of them are stacked together. We all call it palicide. And if you're using electron microscope or using phase contrast microscope, you also could see sometimes inside there is a dot cell. This is called inclusion. And this inclusion usually is the storage of phosphate, which means storage some of the chemical ingredients and some of the nutrients. This is very important characteristics. So we gave you a joke, like two of them in a nightclub, they stack together. And some people will say this looks like a Chinese characteristic too. And this is a Chinese characteristic too. So it looks like very similar to that. Okay? That's the first thing we want to talk. Okay, what is the kind of bacterial diphtheria will cause the symptoms? The symptoms is very typical. If we draw this guy right here, we'll have in the tonsil area pseudo membrane What this means in the tonsil area, if it is a kids, you're going to see a doctor. The doctor said, open your mouth, say ah, and you will see a very soft and greenish pseudomembrane in the tonsil area. If you're using a cotton swab to touch it, it will start bleeding. Of course, the kids will be crying. Okay, that's a very important symptom. The second important symptom will have a swelling of the neck. This neck will swelling like this. Looks like a ball, so we say it's ball neck. Since you have a swelling of the ball neck, that means the lymph node is swelling. Okay, that something happened. Now we want to say something. What are the risk group of Corynebacterial diphtheria? It is kids 2 to 5 years old, and the older people is more than 60 years old. And we have to say that the kids, most of the times it happened, is immigrant kids. Is immigrants. And this has to be careful. I can't say these things all the time, because it is true. 10 years ago, when I first teach, I can say, there is a case from CDC, is immigrant kids from Honduras, from Mexico, from all those Central American countries. That's a big risk group. Why? In the United States, we have a very good vaccine for that. What is a good vaccine for that? It's called DTaP. This is a very good vaccine, and you heard about that. What is D means? Diphtheria. Corynebacterial diphtheria. What is T means? Tetanus. Clostridium tetanus. What is A means? Acellular. What is P means? Bacterial pertussis. This is one shot, 3 jobs. One shot of the diphtheria toxin will solve 3 problems, which is Corynebacterial diphtheria, Clostridium tetanus, and Bacterial pertussis. But you know that this vaccine is not one shot the rest of your life. You need to have the shots is periodically. This is an immune schedule recommended by CDC, published in 2012, a decade ago, recommended for the kids. So you see DTaP, diphtheria, tetanus, pertussis, you have to do 2 months, 4 months, 6 months, 15, 18, and 4 to 6 years old. Lots of shots. Why? They need a lot of the booster. Need a booster because this vaccine is toxoil. This means this is a chemical-like material. And this will be only activate T cell, which means cell-mediated immune. It will not activate the humoral immune. So the immune memorization in the body will be short. Therefore, you need lots of the boosters. But we do have a vaccine for that. And the kids born in the United States is required to take the shots periodically, especially when they were very young. But the immigrant kids, they do not, in the country, they do not have this policy, do not have the vaccine. It's a risk group. Okay, so this is something important that we want to mention. Okay, we want to talk about this toxin. So diphtheria toxin, this is the toxin where they come from. This is toxin comes from the tonsil area. So diphtheria toxin, this is a very typical exotoxin and also a very typical AB toxin. So what means the AB toxin? There is basically 2 domains. There is A domain and the B domain. The A domain, we call it toxin domain. The toxin domain is responsible for inflammation. So what is the inflammation will comes out? If you know, the typical symptom is like a heat, like a red, like a hurt, and looks like a swelling. So that's inflammation. That's an A domain. And the toxin domain, the B domain, it is transmembrane domain. So the transmembrane domain, they will be caused, a very typical symptom is bleeding. That's a reason in the tonsil area you have a pseudomembrane, you touch you using cotton swab, it starts bleeding. It's very soft because it's two domain. And this pathogen is localized. So the bacteria is localized in tonsil area. However, the toxin could be invasive. The toxin could be translocated. Now, how they happen, these harmful impacts, this is to prevent the elongation factor 2 during the DNA translation process. So we will talk about, and this picture which tells you a very good principle behind that. Then the AB toxin, if you go inside of the body, they will become is a complex. This complex, which is we call the indosome, and that indosome, the pH is lower, it's about 5.0, and then they separate. When you look at the picture, you will see the B domain is go out, recycled back to the cell surface, cause bleeding, and find another A domain, they come back. Then the A domain is a toxin domain to prevent elongation factor 2, work with nicotinic adenine dinucleotides, which is NAD, and cause a problem, cause a cell death. So that's a very simple picture, tells you AB toxin. This AB toxin, you can understand it is a pH around 5.0. It's an indosome. Z1 and E. Okay, so that's we want to talk, and we also want to talk diphtheria toxin, where it comes from. This is come from a phage called a beta phage. So this is the same thing we mentioned before, a long time ago. We had a bacterial genome. If the bacterial genome has been invaded with a phage, and the phage genome will be integrated in here. And later on, it becomes a toxin. And it's a diphtheria toxin. This is very similar to a parasite to invade a host, and later on the genomic information of a parasite is integrated with the host. So this process, we have a theory. We call it lyse journey conversion. This is explained at the typical example for diphtheria toxin, how they comes from. Okay, so these are the things what we want to say. Now, because of this toxin, in addition to you have a pseudomembrane and you have a bone neck, what are the other typical symptoms? You have a neurotoxin, neurological toxin, toxication. Then what's the symptoms? Difficult speak, difficult swallowing. When you eat something, it is difficult to swallowing, and difficult speak, double vision. This is the key. Okay, that's a neurological symptoms for that.